Hello guys, welcome back to my channel. This is the continuation of the previous question number 4. So this is question number 4b. So let's get started. An envelope contains 24 stamps as described below. So we have used and unused with 4 different colors: red, blue, yellow, green, and the numerical value also shown. 3 of these stamps, which represent a random selection of 24 stamps, have fallen out of the envelope and are missing. The event G and U are defined as follows. So this is the event G and U. So find the probability of U. So event G is no green stems are missing, and event U is at least one of the used stems is missing. So find probability of U and probability of U given G. Then we need to determine event G and U are independent or not. So first, probability of U. How? So probability of U is probability of at least one of the U stem is missing. So U stem is over there. So U stem is how many U stem? So 3 plus 2 is 5 plus 5 is 10. So it's 10, right? So it's 10. Unused is of course 14. Okay, 14. So at least one of the U stem missing, which means that one use missing or 2 unused missing. Okay, so it is 3 missing, right? So 1 plus 2 is 3 missing. So 1 from the used and 2 from the unused are missing. Okay, because it is at least once. At least once means 1, 2 or 3. So maximum 3. Minimum is 2. So it cannot 0. Okay, plus maybe 2 are missing from the used stem, and then only 1 unused are missing. Plus maybe 3 of the used missing, none of the unused are missing, like that. Okay, so this is how we the flow thought of our question, right? So this is how we manage to understand the question first, and then we need to transform this thought process or the flow thought into mathematical form. All right, so because only one use missing, so use we have 10 stems. Okay, so we can use combination. Okay, combination. So we choose one from 10 use stem. Okay, 10 choose 1, multiply with the 2 unused. So unused we got 14 stem, we choose 2. So why we need to multiply? If you realize over here we multiply this, and then over here we plus. So for in probability, if there are similar case, so this one is considered as case 1, this is considered as case 2, and then this one is considered as case 3. So when we have same cases or similar cases, so we need to multiply them, because one use, so for case 1 is 1 use and 2 unused, so we need to multiply them. Okay, and then for the case 2 is 2 used and 1 unused missing, so we need to multiply them. Okay, between these two cases, case 1 and case 2, when we are going to determine the total probability of case 1, case 2 and case 3, we need to plus, because they are in the different cases. So in probability, if we are dealing with the similar cases, we need to multiply them, and when we are dealing with the distinct or different cases, then we need to plus them, or we need to add them, right? We need to add them for the different cases, like that. Okay, so that's the concept in probability that you need to understand, right? So I'll continue. Plus, so 2 used, which is 10 choose 2, multiply with the one unused, which is 14, choose 1. Lastly is 3 used, 10, choose 3, 10, choose 3. So we evaluate this, becomes how much? Okay, how much? Wait, let me check. 415. Okay, 415. Okay, because we want the probability of u is the number of u divided by the total. So basically this one is basically not the probability, but this is actually the how many event u occurs, okay, or how many the event at least one of the u stem is missing. So it is 415 divided by the total ways of the 3 stems to be missing is basically 24, choose 3. Why 24? Because we have 24 stems, and out of 24, 3 of them are missing. So 24, choose 3 ways. Okay, so in this manner we can find the probability of the u, which is you just type in the calculator. This in return to be 415 over 506. Okay, so that's the first one, probability of u. Okay, for the purpose of the video, I will also find probability of g, because even though the question doesn't ask us for the probability of g, but for this question, probability of u given g, you will need to use, or you need to apply the probability of g inside the conditional probability given over here. Okay, so probability of g is basically probability of no green stems are missing, which means that the only stems that are missing is from red, blue, or yellow, right? So we can write it as, so the total ways of the 3 stems to be missing is 24, choose 3, right? And then because we have 24 stems, 3 of them will be missing. Okay, 24, but we need to exclude. Okay, we don't want to include the green stem, because the green stem is not missing according to the question, because event G is defined as no green stems are missing, which means that these 4 green stems are never to be missing according to the event G, because we define so, right? So because we need to exclude the green stem, so minus 4, like that, which is 20, choose 3 divided by 24, choose 3, which is 285 over 506, like that. Okay, so it's very simple. And then, okay, last one is to find probability of u given g. Probability of u given g is probability of, so according to Bayes' theorem is like this, right? Probability of g. So let's find probability of u intersection g. Probability of u intersection g is defined as the probability of at least one of the u stem is missing and no green stem are missing, which means that we need to focus on the use column, sorry, in the use row. Okay, this row. Okay, we need to focus on this row. So at least one of the u stem is missing and no green stem are missing. But for the use row, if you see, there are no use green stem, so it is over here is 0. So we need to focus on the red, blue, and yellow, three colors of the stem. We need to focus on them merely, right? Okay, because there are just 10 use stems with 3 different colors. So first is 10 10, choose 1, okay, multiply with the 9, choose 2. So this, okay, this is at least 1, because we cannot say event, because this is actually from event u, at least one of the stem is missing. Okay, plus 10 choose 2 times with 9 choose 1. Why 9? Because from the use section over here, from the use stem over here, for example, if red stems are missing, sorry, one of the red stem is missing, so we just left with 2, 2, 5, 10, correct? 2, 2 red, and because one is missing, 2, 2, 5, so we just left with 5, 2, 2, which is 9. Okay, so we can still choose 2 out of 9 stem to be missing, so that's why I wrote over there is 9 choose 2. Okay, first one is 10 choose 1, because overall is 10 and just missing 1. After that, missing 2 out of 9, right? And then plus with 10 choose 3. Okay, 10 choose 3, right, like that. So when we calculate this, we need to divide with, okay, don't forget to divide with probability of g. Probability of g is 2 at 5 divided by 506. Okay, so we'll plug into the calculator. Alright, sorry, my mistake. So it is not divided by probability of g, because probability of g is referring to these p probability of u given g, but this is probability of u intersection g, so they are different. So we need to divide by the total possible way of the 3 stem to be missing, which is 24 choose 3, right? So this will be 24 choose 3, so I got 885 885 over 200 2024 2024. Okay, so how okay, let me see. Okay, so we already get that. So probability of u given g is 885 over 2024 divided by probability of g is 285 divided by 506. So just press into the calculator. 285 divided by 506 is 59 over 76. Okay, so we got that right. So I hope everything is correct. Okay, so I got that. I'm not sure if this is the correct answer or not, but I hope, just pray for the answer to be correct. Right, so next is to determine if event u and g independent or not. Okay, so let's assume if u and g independent, then the relation should be probability of u intersection g should be pu times pg, and then we know that pu probability of u is, which one is this part, 415 over 506 415 over 506 multiply with probability of G is this one. 2 at 5, 506. 2 at 5, 506. So this is about 0.462. Okay, and our previous one is this, right? This is also probability of U intersection G. Okay, this one. But is it the same? If it is the same, then it is independent then. Okay, and at 5 224 is 0.44 maybe 437. So if you see, this is 0.437, this one is 0.46, so it's different. Okay, since P U G is inconsistent hence it is dependent event. Not it is, sorry, there are dependent event. There are dependent event. Okay, so over here, if we calculate using the probability of the independent event, okay, probability of P intersection G for the independent event is this formula. We calculate it to be 0.462, but previously we already calculated also that using this formula, using the conditional probability formula, we get that the probability is 0.437. So they are not the same, so they are inconsistent. Hence we can say that because the value is inconsistent, which means that the value is not the same, so it is not independent. Okay, not independent, i.e. there are dependent events. Okay, there are dependent events, right? I think my video is takes very long already, so it's almost 20 minutes, so I don't want to be so long. Yeah, but this type of question is quite difficult and challenging, so I hope I didn't make any mistake during my explanation. Yeah, alright, that's all for my video. Thank you, and comment down below for any feedbacks, for any, if you notice there is a mistake or something, just comment down below. And yeah, till next time, thank you.